services, the new reactive services. Just a reminder that this evening the OSGi coffee is here, so the OSGi Alliance board and all those guys will be around if you've got general questions.
So thanks. Welcome all to my talk, from logging to monitoring to reactive insights. First, something about me. My name is Christian Schneider. I'm married and, as you can see, father of 2 lovely daughters. Well, can't see too well, but for the last 6 years I worked at Talent as an open source architect. I'm especially noting this because I started this presentation on terms of Talent, and then since October I started a new journey and switched to Adobe. I'm now working on the Experience Manager platform team. So it's still a lot about Apache projects, about open source, but with a little bit different focus. I'm also an Apache member and committer at several Apache projects. And if you want to contact me, you can reach me at SchneiderChris at Twitter. I also got a website, liquidreality.de, with some of my personal projects, but more importantly, tutorials about OSGi and especially Karaf. So if you're interested in that, that might help. So let's look into what we'll learn today. I'm looking into Apache Karaf Decanter. It's a sub-project of Karaf, and it's basically an adapter to monitoring solutions. And I'm showing it together with Elasticsearch and Kibana, so it's a quite nice setup together. I'm also showing approaches for central monitoring and logging when you have a bigger setup of systems. And in the end, I'm looking into reactive streams and how they can be used to kind of refine your informations, get higher level informations whenever your logging framework is not enough. So let's start with the basics. Logging in OSGi, there are several out-of-the-box frameworks that can do that. PAX logging, logback, log4j2. Actually, PAX logging relies on one of these two in the back end. And basically, they have some adapters, but more or less, normally, you write your files. So it's a quite limited solution for logging. There is also monitoring out of the box. There is a JVisual VM, which is brought with the JDK. You can look into MBeans, you can look into the status of the JVM, something a little bit about the operation system. You can do profiling. There is also Hot.io, which goes a bit beyond that and has some nice plugins for certain frameworks or technologies. These are great tools, but they are most of the time developer focused. So if you're developing your solution, you can use them to get some information on what's going wrong maybe, but it's not so good for a real production environment where you normally will not connect with JVisual VM or something like that. So actually, what do we need in production logging on, let's say, also the enterprise scale? So one thing is we want it to be central. We don't want to go into each machine and look into logs or look into a web API of each machine for managing. We want to have it in a central place. We also want a history. Like in a JVisual VM, you can look into an MBean and see a bit of the history, but just since you started. So this is also not really for production. We more like a history that is like several days or weeks back at least. So what happened last weekend when we got a call that the machine is not working, or that the web front end was slow or something like that. We need something to diagnose that. We also want to have a drill down. So we start normally with a very broad idea where to search, like a certain machine or a certain service or a certain time frame. And then we will drill down into what is the root cause of a problem. And last but not least, we also want some kind of custom processing whenever the logging framework or monitoring framework we have is is too limited for us. We want to be able to enhance it to what we actually need. A typical solution is the ELK stack, Elasticsearch, Logstash, Kibana. And basically, you can actually use that together with Apache Karaf or any other OSGi stack. You can just run your OSGi application and install a file beat and a metric beat together with it and configure them to suit your log format and attach to the right JMX port and get all these informations they can send to a Logstash server and finally go into Elasticsearch and you can look into it using Kibana. So that is working, but it's quite a lot of effort to set up. And Apache Decanter makes it a lot simpler. You can simply install Decanter as a feature in Karaf, and out of the box you have some connection to Elasticsearch, and you don't have to set up much to make it work in a pretty good way. So how does the Decanter architecture look like? It's pretty simple actually. So the main things are collectors and appenders. Collectors get yourself information from some source like log or JMX or whatever, and they send all to event admin to certain topics, and appenders are responsible for listening to event admin and sending out to several sinks of information like a database or Elasticsearch or JMS, mail, whatever. So actually there's a bit more in Decanter, but that's the main concept. And what do we have as collectors and appenders? There's PAX logging, which means everything that goes into your logging framework in Karaf, whatever logging front end you use, you can intercept. There's JMX, that means all the ambience you have can be pulled regularly and sent to your logging system. Event admin, whatever happens on the event bus can also be tracked, like all the bundle events, service events, all that you can work with. There are also special modules for Camel, ActiveMQ, and quite a few more. So it's easy to set it up and get some useful information out of it. On the appender side, there's a big list, file, database, Elasticsearch, Kafka, JMS. I will be mainly looking into Elasticsearch and Kafka for this talk, but there are a lot more. So how can a setup of Decanter for a single machine look like? Typically, I want to have the JMX collector, a log collector at least, and then whatever plugins you want to have additionally for the type of frameworks you use. And a typical setup is to somehow send to Elasticsearch. There's a direct Elasticsearch appender that can directly plug into it, but we'll later see that there are other possibilities. So for multiple servers, Kafka is a nice solution in between. You can also send directly to Elasticsearch cluster, but in many cases, it's likely the ELK stack is also set up in many enterprise environments. You have several servers that are enhanced for logging to Kafka. With Decanter, you can do that inline. With ELK stack, you would have these beat components externally. And you send it to Kafka, and from there, you can use Decanter to take that from Kafka again as a collector. There's not only a Kafka appender, but also a Kafka collector. Maybe post-process some of that information and send it out again using the Elasticsearch appender to a normal Elasticsearch instance. And you can look into all this information with Kibana. You can also nicely combine with an existing Logstash installation. So if you have this ELK stack already in place, you can nicely plug Karaf Decanter into it. So for example, here we have some Spring Boot or Tomcat with beats set up for Kafka, and a Logstash server in the backend who does the post-processing and feeds into Elasticsearch. And we can just plug a Karaf with Decanter into that setup. So you don't have to change your whole logging and monitoring stack just for that. One other important part is whenever you do SOAP services or REST services, then you often use SIGSF, and you typically want some tracking of the messages that come in to a server, that are responses sent out. And also on the client side, you want to see what is sent out, what responses do you get back, because there can be something broken in the middle. So response sent out from a server does not have to be collected on the client. So it makes sense to have both be able to intercept that. SIGSF already provides, now not so new anymore, message logging feature. It's not the old message logging that is now deprecated. It's in a separate module in SIGSF. And the nice thing is, it doesn't really use Decanter directly or whatever. It just sends out to SLR4J, and all the metadata that it collects, like, for example, the HTTP response at a REST call, or the service name, or the machine name, all is collected as MDC properties and sent to SLR4J, and Decanter can just use the normal logging collector to pick all that up and make pretty good use out of it. So additionally, it provides support for message IDs and correlation IDs. Message ID means when a client sends out a message, and the client message ID for this message is created. It's a unique ID. It's added to the request, and when the server receives that request, this message ID is still present and will be taken and also logged on this side. So you can also always say the message sent out here is the same that's received here, so you can correlate these two. And there's also a correlation ID for exchange in SIGSF. That means the request and response get the same correlation ID and are also logged, so you can also correlate request and response together. So this is a nice thing. It's standard in SIGSF. Doesn't have anything to do with Decanter, but works perfectly with it. And there's also the logger name in SLR4J is set up as a certain prefix for SIGSF logging, and then the service name, and if it's a request or response. So you can set up your logging to send messages for certain services or block these messages, because these request and response messages can be big with content, and so you can switch it on and off on the running system without changing any code, just by configuring your logger. It's also possible to extend Decanter. Actually, Decanter itself is a very simple system. It's not really related to Karaf technology much. It uses declarative services and attaches to event admin. So you can do the same. You can write code that listens to event admin, takes these events and does something with them. So you are an appender. So an appender is not a certain interface. It's just using certain topics and writing the event admin messages in a certain way, kind of like a map. It's also possible to filter and enrich events, because you can send them to one event admin topic, have a filter that bridges to another topic, just sends parts of them, and from there it goes to the appender. So you can make it from very simple, which is the default, to quite complex. And if that's not enough, you can use a kind of complex event processing using a framework I kind of founded, Reactive Components. I'll have a separate talk that concentrates on that, but I will show a little bit about that later. So some of these event processing use cases are one thing I implemented as a kind of showcase. It's not very useful, but can do it. You can have events when a bundle is started and stopped, and you can basically remember the started bundle time, and when the same bundle is stopped again, you can note how long it was up and send this out as an event. This can be easily done with that framework. We can say we send the alert message when there are more than a certain % of errors in a windowed time frame. We could correlate request and response into one message that is sent to Decanter, so you don't have to correlate them on the kibana side. And for example, you could have a source that sends a lot of events. I show that with a source that sends, I think, 100 events per second. And you say, I don't want all that to go into my log. I only want to have one event per second and just sample one of these events or sample an average of these. Also, that's pretty easily possible. So let's see that in practice. Unfortunately, I had to restart the machine, so I have to restart Elasticsearch and Kibana. So I'm brave. I'm sending starting Karaf clean. So that's basically Karaf like you would get it out of the box. And then, oh, where's my Eclipse? So just need to retrieve the README with the features to install. It's happening again. Well, this happened during the last session when I tried to work a bit more on my presentation. Eclipse stopped working. No idea why. I reinstalled it, all worked again. Now it doesn't work again. Well, the good thing is we don't absolutely need Eclipse for that. So let's see one more basic editor. Can I somehow close it? Yeah. So this is commands you can do on the Apache Karaf console. I just do them so you can work a bit on that. I add the repository of Karaf Decanter in a certain version. I install the collector log, the collector JMX, collector event admin, and the appender for Elasticsearch. So, looks a bit strange. I'll just do it again, maybe, yeah. No idea why that happened, but normally it shouldn't. So basically this means Decanter has some collectors and sends to Elasticsearch. Then I add this Reactive Components framework, which we'll see later what it does, and a component for event admin and the reactor project. Basically this Reactive Components, at least the examples, are based on the project Reactor, which is the base of Spring 5 also. So this is not yet so popular, but it will be very popular in the future. And nicely, it runs on OSGi and doesn't have any additional dependencies. So it's pretty nice as a foundation for kind of event processing. Also install CXF with the REST support and the logging feature, and install my two examples. The first example is a simple REST service and a command to put some load on it. And the other is for this reactive processing. So, but that's enough. Let's first look into Kibana. Let's see. So I already set up some dashboards. So one is for example, CXF messages. Don't know if we already, I guess we don't have any at the moment. Let's look into log. So what it shows is, it's a bit small on that screen. View, let's see, full screen. A little better at least. So what we see is some diagrams for one log level. So at the moment it's all just info level, and certain logger names, the top of these, and in the lower here we see the actual messages. So we could now say what we really want from them, like we want to see the log level. Does it work? This screen is a bit small. I don't know if that works. I hope it's taking that. The logger name, for example. So this activates these in the table. Here, for example, we now see logger name. So it's a bit small here on that screen, but you can basically create your table with the typical, I use the log level, logger name, the message, so you can see what is actually logged there. This way it's already a bit better at least. I'll add the message at least. So now we can close that. And now see a typical log. We can configure what columns we want to see. That's the logger name and the actual message, and we can add whatever we need from that. And the nice thing in Kibana is we can say we take that logger, that's CXF Management Instrumentation Manager, and now the table just shows the logs of this special logger. We can also, in the top, go to a certain time frame and limit that. And can I close that again? So basically, this is the drill down part. We can drill down by time or by other things, other properties to limit what we see. We also have access to all the JMX beans and can create visualizations from them. So I selected one JMX bean by object name and put two load statistics here, average system CPU load and process CPU load, and we can see them in the diagram. And again, we can do it for every time frame. We can really put a lot of data into Elasticsearch and go back weeks, and however Elasticsearch is configured to hold that data. Now let's look into, I've got a really simple little service. If you write anything, it just echoes it. If you write coffee, you get an error 418, I'm a teapot. And basically in Kibana we now should, I hope we see that soon. I guess now we see something. We see those messages. We see a certain number is 418, a certain number is 200, so okay. And we see the responses there, and here is an exception, and here I'm a teapot, and oh no, that's a different one. We would need to select for this, for example, fault out. Then we would just only see these. This was a different logger. So as you can see, we can see the normal logs. We can see special informations for the REST messages. I can also show what exactly is shown here. You see the certain MDC values. This works for CXF message logging, but you could just enhance your application to just add MDC values to any log message you want to create, and Decanter can split that up into separate columns, and you can have all that in Elasticsearch, and each is a separate field in Elasticsearch. You can search for it. So for example, I could show all messages with this response code, or with fault out, or whatever I see here, and do quite nice queries on that. So unfortunately, I can't start Eclipse at the moment, so I have to show it here. So the sample rest is, I guess, not so interesting. What we can do here is I've implemented a command here for the Karaf shell. Load a start with a percentage of errors, and now it sends a lot of requests. I could look into them from the log and see this is how the normal logs looks like that for that. And I could go back to kibana and should, when I remove that, I should now have a lot more messages. For example, here 167 and 40 failures. I could now say, now produce 90% failures, and it should soon adapt with a larger percentage of errors to that change. So I'm not sure if that time frame still works. Let's say last 15 minutes. So you see, there's already now a bigger percentage of errors in the recent time. And you can drill down to, for example, why that happens. And let's see now these reactive flows that I created. Of course, this is not the perfect way to look into that. For example, this is without reactive components. This is just event admin. So I created a runnable in a component that starts and executes a thread, and every 10 milliseconds it sends an event to event admin to the topic net are fast. So this is something we don't want to have on our Elasticsearch every 10 milliseconds. This would fill up our system too fast. And now we can have something like this in between. This is now showing how these reactive components work. Basically, we see here our component. This is an interface for these reactive components. Very simple, just two methods. We see them here. You select which component you want, the event admin one, but this is not typed for event admin. You're not coding against event admin directly or any other technology that is covered there, just against that general interface. A bit like camel components, but with a lot less exposure to all the inner workings. Camel has not a nice API, and this API is very, very small. So what you can do is you have this event admin component and say from. This is something that emits data. We say from this topic, and we want a map as a type out of it. And we can say we want to send to something. This is something to send information into. It's like in Apache Camel, if you know that. Decanter collects sampled. So we send into a certain topic again, also a map. And this is from Project Reactor, from the Spring guys, a Flux. This is this reactive streams compatible thing. You start from this event admin component. You sample every second. So that means every second you take an event, and all the others you ignore. And what comes out of it, you send to this topic. So basically, it's a bit like in Camel, but a lot more modern. It's reactive, and you can do a lot of interesting things. Unfortunately, I'm not a specialist in that, so I just did a bit very simple examples. Another example is, so we can now also look into that. That's already running. So if I look into that, we see that are a lot of events coming. And if we look into this topic where the sample data comes out, it's just one event per second. And this is what also goes to Kibana now. So the other thing is, this is about this bundle runtime. It's working in the same way. We're also talking to the event admin component. This time we're looking for standard OSGi events or OSGi framework bundle event star. So started, stopped, installed, and so on. And 2, we again go to Decanter collect. Everything that is in Decanter collect will be sent to Elasticsearch or whatever you configure as an appender. Here we name it bundle runtime. And we say we listen to these event admin events. Here we compute the running time of the event. We filter the events that are empty because if we don't, so if we have a started event, we will just log the time and not send another event. If we get a stopped event, we will log the time, we will compute the time and send it out to this topic. And this here is just to compute the running time. So noting the on started, it puts the time into a map per symbolic name, and on stopped, it creates an event with the time running and returns this as an event. And if it's not stopped event that it's collected, it just returns an empty hash map. This is why we have the filter up there to not send out these empty events. And so we could stop a bundle 20 of, hope it's not something important, start and stop again, and hopefully we should have this event in Kibana now. I hope I have the correct search for it. It should be, to look into that. Bundle.symbolic name or time.running is probably even better. So we can go into this discover and show where are these fields. I can't find it that fast. Let's see, I guess we should be able to use that bundle star. Doesn't that work? Thought it should work. Bundle runtime. Not sure why we don't find something at the moment. Don't know. So let's skip that. So basically what I have shown in the demo is how to set up Decanter. It's just installing some features, and the defaults are already prepared when you want to log to localhost to Elasticsearch. You can just install Elasticsearch and Kibana as default installations, and it will already produce a lot of interesting informations. We also saw that you can extend a Decanter. You can set it up for real big environments with Kafka or with an Elasticsearch cluster. You can also fit into Logstash environments, and you can enhance it with these reactive components and reactive streams. So that's all from me. Any questions?
Any questions? No? All right, well, Christian, thank you very much.
Good. And I'll send around the presentation on Twitter. So Schneider Chris, you can follow. I will also use some hashtags to make it seen on the conference, and will also, of course, forward it to the conference for posting. And all my code is available on GitHub. It will be linked here, Reactive Components and this demo code. So you can look up all I did.
Okay.
Thanks.
Back to back.
Yeah, important thing.
I'm dead if it is.
Exactly.